barren planet becomes Earth as we know it. It all began around 4 billion years ago. Life spawns. Gradually it spreads to every corner of the planet. Throughout millions upon millions of years, evolution has brought forth an immeasurable multitude of animals and plants. Yet, as different as they may look, all species are related. The first to discover this was an Englishman named Charles Darwin.
Darwin completely changed the way we see ourselves, the way we see the whole of life.
What is intelligence? Why do we have to sleep? And what's the difference between man and animal? The wall that divides us is becoming more and more permeable. Time and again, disaster wreaks havoc with life upon Earth. But until now, it has always survived. Scientists probe the big questions of life. They come across astounding facts and acquire revealing insights about the great moments in evolution. Flying is easily one of evolution's greatest inventions. Over millions of years, birds have perfected their skills as natural aviators. Yet, as simple and graceful as it appears, flying consumes enormous energy. Before they could fly great distances, birds needed to develop very specific anatomical and physiological features. 50 billion migratory birds are proof that they did so. By taking to the skies, they have spread across our planet. For birds, there are no borders. They negotiate ice deserts and vast oceans. Some species spend almost their entire lives in the air. Each of them has its own peculiar way of flying. Yet, the things they all have in common are wings and feathers. Flight feathers are a marvel of aerodynamics. Tiny hooks make them interlock and detach as required. This amounts to lightweight stability. Feathers and flying go together like the proverbial chicken and the egg. At least, this is what we had taken for granted. But then, in 1995, spectacular new fossil discoveries were made in China. Currently, no other site on Earth provides us with so many dinosaur fossils. And many of these species appear to have been feathered. Can these be classified as early precursors of birds? And what purpose did their plumage serve? Their physical traits clearly show that they didn't fly, because they couldn't. Around 160 million years ago, Epidexipteryx climbed through the primeval forests. With a length of just 45 centimeters, it was one of the smallest dinosaurs ever. What made it unique is an excessively long middle finger, an ideal tool for angling. Even back then, a juicy meal attracted competitors. Another feature that distinguishes Epidexy, its 4 long tail feathers. Are they the first indication of vanity? Could it be that the little saurians had a sense of aesthetics? We shall never know. Yet there were feathers long before any prehistoric species began to fly. An insight that is highlighted by a find from Germany. Several years ago, researchers unearthed the remains of a baby dinosaur from a chalk pit in Bavaria. This specimen is in excellent condition. An examination using ultraviolet light has unlocked its secrets. Its species, Sciuramimus, was an original saurian. Yet their bodies were densely covered with feathers. But these were more the downy, insulating type, rather than flight feathers. It's a sensational find, slightly more than 150 million years old. A discovery of far-reaching consequences.
Until the discovery of Sciuramimus, basically all the feathered dinosaurs that we had were close relatives of birds. So I mean, to have feathered dinosaurs was already quite a sensation, but all of these animals were quite close relatives of birds. Scuromymus is a much more basal predatory dinosaur and shows us that like feathers or feather-like structures were present in dinosaurs long before the origin of birds. And based on our present knowledge, we have to assume that basically all dinosaurs had feathers.
This doesn't mean that the mighty T-Rex and his kin were tramping around all clad in feathers. The larger the gap between the lineage of dinosaurs and that of birds, the more their plumage resembled hairs or a warming coat of down. Or possibly some decorative plumage, which might have graced the tail or the head. But how then did the early birds actually develop their ability to fly? The answer continues to be a matter of contention among researchers. One school of thought is betting on the microraptor. It would sit high in a tree and then glide downwards, relying on the feathers of its forelimbs and those on its hind legs and tail. The first flights might have looked as elegant as that. Evolution applied a veritable test range to try out a variety of models and approaches. In the primeval forests of the Jurassic era, the feathered species of saurians were competing for the resources of their habitat, and some, to improve their chances, developed a means to fly. But some researchers reject the glider theory. They believe that the first flyers took off from the ground. You start by running, and sooner or later, you're airborne. A similar technique was used by the first motorized flyers some 100 million years later. They too went through a process of trial and error, of learning and of optimizing. Man determinedly advanced technical development. In contrast to nature, he left nothing to chance. That's why it took a mere several decades until aircraft became reasonably safe contraptions to carry us from A to B. But there still is nothing that glides through the air with the silence and seeming weightlessness of birds. And so today, they populate our planet with their dazzling diversity of color and shapes. No one knows how many species there are on Earth, let alone how many existed in previous ages. It is assumed that throughout the course of evolution, 90% of them became extinct. Take Dimetrodon, although its prospects looked bright. About 300 million years ago, long before the age of dinosaurs, it lived on a clod of earth where today grow the forests of Thuringia. Dimetrodon and its kin were members of a group of reptiles which are presumed to have been the precursors of mammals. Even back then, the world was divided between passive vegetarians and fierce carnivores. Dimetrodon was one of the top predators of its time. Its prey are blissfully unaware of imminent danger. Its flamboyant dorsal was probably meant to impress, like the antlers of a deer or the plumage of a peacock. Dimetrodon owed its success to its speed and to some decisive innovations. Its contemporaries still had to gorge their food, while Dimetrodon was able to bite off single chunks due to a set of unequally shaped teeth, a common feature of all later mammals and of enormous advantage. Another significant detail to put Dimetrodon in a line with mammals, be they hedgehog, horse, ape, or man, is an aperture in the skull, the so-called temporal fenestra or window. It was probably the ultimate prerequisite to allow the mammal's brain to grow and to develop. However, Dimetrodon's time was up. 250 million years ago, disaster struck. When it was over, there was almost no species left alive on the planet. To date, the cause of this mass extinction has not been ascertained. Volcanism, on a gigantic scale, may very likely have played an important role. Especially since it wasn't a single volcano that erupted. The world over, Earth spewed forth seemingly endless streams of lava. This spectacle lasted for more than 1 million years, until the deposits measured 3 kilometers in height and covered an area equal to that of today's USA. More than 90% of all species in the oceans, and almost as much upon land, had become extinct. Among those vanished forever are Dimetrodon and his relatives. Almost all corals, the trilobites, as well as innumerable species of insects. Yet the extinction of species set in at least 10 million years before the volcanoes first erupted. Was Earth hit by an asteroid? Convincing evidence has not been found. According to most recent research, the disastrous chain of events began in today's Siberia. Deep inside the Earth, immense forces were churning the rocks of the Earth mantle like a giant mixer. The hot rock pushed upwards, exiting at hot spots. Volcanic gases spewed forth even faster. In contact with water, they changed into sodium chloride and sulfuric acid and almost snuffed out every living organism on the planet. Over time, the gases altered the atmosphere. It had become a lethal cocktail of poisonous gases, sudden temperature changes, and dangerous ultraviolet radiation. Methane and greenhouse gases heated up the planet and destroyed the ozone layer worldwide. That is why most species of animals and plants died out before the giant streams of lava poured over their habitats and killed off most survivors. Consequences were global. Earth had become barren and empty. Almost. Some species had survived. Otherwise, there'd be no mankind today. Lystrosaurus was a so-called disaster species. They roamed an otherwise empty landscape in great herds. Their humble way of life enabled them to benefit from the new conditions. They were excellent diggers and would temporarily seek shelter underground. The primeval bunkers offered protection against dust and scorching heat on the surface. And so, with neither predators nor competitors, they proliferated across wide expanses of the planet. Their migrations prove that, back then, the continents of Africa, India, and Antarctica were still unified, or at least closely connected. For several million years, Lystrosaurus was the undisputed ruler of its global domain. But again, evolution began to gather pace. Conditions for life began to change, much to the disadvantage of Lystrosaurus. Its reign drew to an end. Yet we reserve a place of honor for the little vegetarian, if only in museums. Why does one species become extinct while another survives? What determines the winner and the loser? Paleontologists at the University of Bonn wished to discover what changes occurred in the world's oceans after the disaster had run its course. The Sierra Nevada is providing them with ample clues, and if you know how, you can easily determine whether it's a fossil or just a piece of rock.
Most bones readily absorb saliva. If I lick it, and it happens to be bone, it will stick to my tongue. And what's also helpful, it stinks. Knocking on it will set gas free, since crude oil within the bone has preserved the organic material. Hence the stink.
Every single bone that has been collected here is a leftover from some aquatic animal. Where today the desert is spreading ever further, 250 million years ago, you would have looked over a shallow, marginal sea. After most of life on dry land had been wiped out, this sea was devoid of life except for a few mussels and some primitive squid, and it would remain so for several million years. Fossilized bones proved that there was new life after this long hiatus, and they belonged to a kind of species that did not exist in prior stages of evolution. Ichthyosaurus, the fish saurian. Its story began long before the saurians we normally think of.
I came up along here and noticed some small vertebrae. When I went on, I found remnants of some larger ones. When we had assembled them, we could see that it was a small spine inside the rib cage of a larger animal. I knew at once that this was the fetus of a fish saurian inside his mother. We then took the whole set of bones to Los Angeles for preservation.
Martin Sander named the mother Martina. Evidently, she gave birth to living offspring, which is most unusual among reptiles. Paleontologists have one explanation. Reptiles had begun to move back into the sea, a first in the history of Earth. They were amazingly similar to our dolphins as they adapted to life underwater, which illustrates that similar challenges bring about similar solutions. The babies developed inside their mother's body. There's no way to determine the gestation period, but one thing is evident. Since reptile eggs die off underwater, fish saurians gave birth to living young. Just like our present-day dolphins many million years later. The devastation of most of the planet had made way for new forms of life. Evolution gradually filled up the gaps. Fossils tell of eras long past. Each discovery expands our knowledge. And the rocks of Nevada held another sensation for the researchers. These bones once belonged to a mighty predator, a fish saurian like Martina.
It's called Teotihuacán, meaning ruler of the sea. It was up to 12 meters long, a subsurface Tyrannosaurus, a top predator who would devour anything that came its way.
Teotihuacán isn't merely of interest because of its sheer size. It is proof that only 8 million years after the Great Disaster, life had made a complete recovery. Even the place of top dog in the food chain had been reoccupied. For Martina and her young, its presence would have made life more difficult. The giant fish saurian's favorite prey were other fish saurians. It was the first really huge predator to prowl the oceans. Sharks and orcas would appear only very much later.
Not too much farther.
The giant skeleton is carefully dug out of the rock. It takes a helicopter to carry it away. At the university lab, its bones will reveal many insights about Earth after the Great Disaster and the dynamics of its ecosystem back then. Finally, it was the dawn of the dinosaurs. For more than 150 million years, they were the superior species on the planet. In time, they occupied all ecological niches. Again, species came and went, until another disaster threatened to eliminate life on Earth. 65 million years ago, Earth was hit by a devastating mass from outer space. For the dinosaurs too, the end had come. Life on Earth would never be the same again.
It would be a mistake to suggest that mass extinctions are themselves selective events. I mean, they're catastrophes which wipe out major groups of animals and plants, and that clears the decks for a whole new flowering of evolution.
Some innovations of evolution have withstood all disasters. The egg, for instance. As different as these animals may be, they all lay eggs. Fish, frogs, as well as insects. And since these eggs are soft and slimy, they must be kept in a fluid environment to be able to develop and hatch. Eggs with hard shells were only brought forth by reptiles, which then became independent from the need for water. Most reptile species leave breeding to the warmth of the sun. But that doesn't mean that their offspring are left to themselves. After 3 months in its egg, an Argentinian caiman hatches and is soon followed by its siblings. Instinctively, they set off for the next body of water, calling out for someone as they go. And there she is. The mother clearly recognizes her own offspring and will help with the arduous journey. Having safely delivered the first, the mother returns to the nest at once, as some of the little ones are having a hard time breaking free from the shells. Their mother helps them, using her sharp teeth as delicately as possible. Motherly care is another innovative feature in the evolution of reptiles. Even dinosaurs laid eggs, and although they didn't survive the upheavals of their era, the egg, as such, did. Argentinosaurus laid them in vast nesting fields. Yet wisely, the colossal parents avoided sitting on them. A freshly hatched Argentinosaurus weighed around 5 kilograms. That's nothing compared to its adult size. 30 meters long and weighing up to 70 tons, they were the giants of their time. For reproduction, Argentinosaurus relied on mass. In the nesting fields, more than 10,000 hatchlings emerged at the same time. An opulent banquet for predators. Most of the little Argentinosauruses would end up in their stomachs. But having reached maturity, nothing could pose a threat to them, except, alas, a meteorite. The egg made reptiles and birds independent from water. For most species, this was a giant leap forward. For some, however, it just meant strenuous exertion. Each year, emperor penguins will travel up to 200 kilometers across Antarctica to reach their breeding sites, where the eternal ice never melts. Each female lays a single egg. Sitting on it is daddy's job. The time in between is crucial. Should the egg be exposed to the snow for too long, the embryo freezes to death. Made it. It's cozy and warm under the belly flap. Outside, temperatures can drop to minus 20 degrees Celsius even in summer. 9 weeks on, the offspring hatch, almost simultaneously throughout the colony. This is definitively a cold start. It would seem much more convenient if the embryos could gestate in their mother's body. But inventive as evolution has been in other cases, no species of bird has evolved beyond this step. They all lay eggs. The success of mammals is based on live birth. Although they account for only 1% of all species, mammals during the past 200 million years have spread across the entire planet, both underwater as on dry land. In the beginning, individual specimens were rather small. There are several features that distinguish mammals: a coat, breast milk, but before all else, it's the fact that the offspring gestate within their mother's womb. But here too, it all begins with a fertilized egg cell. This moves through the oviduct and settles into the uterine wall. There, it merges with the mother's tissue, and a new organ, the placenta, develops. The placenta conveys nutrients to the embryo as it grows, well protected in the amniotic sac, a tiny reservoir of ocean all its own. And when danger lurks, it's simply carried along. The first steps. Having given birth, mothers do what gives mammals their name. Mother's milk provides the infant with everything it needs. This is one of the truly decisive innovations of evolution. It's also the origin for the long and intense relationship between mother and child. Human infants, however, lack almost everything it takes to survive. Left to themselves, they're utterly helpless, quite unlike those of our nearest relatives. A baby orangutan, for instance, is much less dependent on parental care. But why has evolution arranged things this way? Scientists long assumed that walking upright narrowed the pelvis until the birth canal became impassable for the head. But apparently, this is not the decisive cause. It's the hunger of the fetus that, after 9 months in the womb, provokes birth. Its demand of calories increases week by week. At first, the mother can meet the demand, but only to a certain level. When it can no longer be increased, birth will begin. As different as the individual development may be, there is one thing common to almost all living beings. More than 99% of all species do it. Sex is one of the most successful inventions of evolution, yet a most enigmatic one. Why must we undergo such elaborate exertion to reproduce? Because sex is much more than mere coupling. First, one must find a suitable mate, then court and perhaps even conquer her. The male will always convey the same message: I'm the strongest and the healthiest contender, your best choice to sire offspring. It's a ritual repeated since times immemorial. No matter how big you are, or how small. It's a fight for exclusive access, so it's well worth the maximum effort. This is evolution's way of ensuring that the genes of the worthiest are passed along. The the winner may approach the object of his desire, while others are merely glad to escape with their life.
You might think that the most efficient way for a female animal, say, to pass on her genes is simply to clone herself, rather than throw away half her genes in each offspring and mate them with those of a male.
The theory of evolution cannot explain everything. Why we engage in such elaborate efforts to find a mate remains an open question. Perhaps it's all about mixing the proper genes to enhance our adaptability. But how can we know that it's Mr. or Mrs. Right? Our genes themselves will take care of that. Outward features of attraction aside, we are controlled by a very less conscious element of mating. We smell one another. Smell is a decisive factor in any mating process. Evolutionary biologist Manfred Milinski's experiments with sticklebacks provide ample proof for this observation. And he's convinced mankind too is guided by the nose.
Anything else that rushes through our mind is irrelevant. Other considerations may come later. If, on the first encounter, a guy smells bad, even if he looks like Humphrey Bogart, he doesn't stand a chance.
Milinski has set up a test. He asks several men to sleep in a colourless cotton t-shirt. The following morning, when they hand it back, the cotton fabric will retain the body's scent for some time. In preparation for the actual test, Milinski had blood samples taken from everyone involved and analysed their immunogenic status. Now it's her turn. Which t-shirt smells best? This one was worn by a man whose immune system strongly resembles her own. Unattractive. So are the next samples. As it turns out, she is unconsciously selecting the one candidate whose smell promises the most protection for her offspring. She opts for number 5. She wouldn't mind a date. So, what has he that the others lack? He simply has the right tools. There are fragments of disease-bearing pathogens encapsulated in our body cells, which are caught and fought by the tools of our immune system. Every human being has a specific set of them. Some pathogens will be defeated, others will survive. So when choosing a mate, we're merely trying to complement our set of tools. The wider the range of tools we provide for our children, the better equipped they will be to fend off likely pathogens.
This mechanism motivates us to search for suitable mates, to ensure that our children will be as immune to disease as possible.
Each one of us is equipped with our own set of immunogens, which give us our individual body odor. So, smell selectivity is the key. In this lab, they are creating perfumes made to measure. But can we actually recognize what works for us best? A synthesized perfume especially for her. B, a different feminine fragrance. She senses instantly which scent will complement her own. A wrong choice might have undesirable consequences. It doesn't really matter when it's only a flirt, but sooner or later it will be critical for the health of our children. And that's where, hopefully, our sense of smell will guide us. That's why evolution invented sex, to avoid diseases. At Boston's Harvard University, scientists are also pursuing this goal. But they have chosen a different approach entirely. George M. Church is a pioneer research geneticist, and a very transparent one. His DNA code is on the net, along with his height, his weight, and even his illnesses. His so-called Personal Genome Project aims at 100,000 volunteers to follow his example. However, the transparent human is a concept still viewed with considerable concern by many.
Sometimes we're concerned about the wrong things. If everybody hoards their personal information, then each of us loses. We all lose. But if we pool them together, and there are various strategies, I mean, ours is just one of the more radical ways of doing it, to make a point. If you can share it, then you can start seeing cause and effect in ways and cures.
Professor Church is experimenting with the cells of pigs with the aim of modifying their organs to suit the human body for transplantation. To achieve this, the pig's genome must be modified until they are no longer identifiable as alien invaders by the human immune system. And it's possible, due to a breakthrough in genetic engineering. The geneticist's magic wand is called CRISPR, the acronym for Clustered Regularly Interspaced Short Palindromic Repeats. It's a tool to excise predefined sequences of the DNA chain and to implant a new, different sequence. This procedure can be applied to numerous sections of the genome. To manipulate mosquitoes to stop them from transmitting malaria, or to turn pigs into organ donors. Theoretically, it's even possible to interfere with the human genome, to eradicate diseases, but also to create the perfect baby. Yet, is this the future we want?
Biologists can certainly see and should see multiple futures, should see all the different futures that could happen, the futures that happen if you do nothing, the futures that could happen if you go back and say, oh, we're not going to use any of the technology, we're going to go back to the caves, or the futures that could happen if we do various kinds of radical change, eliminating diseases, taking us to foreign environments where we're not well evolutionary adapted, like Mars.
Life has always been under pressure to adapt to new conditions. And lest they should turn particularly unpleasant, you move on. A caravan in search of water, driven by drought and the need to find food. On the African continent, long-distance marches like this are a regular event, year in and year out. During the dry season, the arid soil turns the steppe into a life-threatening environment. Each year, more than 100,000 wildebeest migrate across eastern Africa. But between them and the rainy regions in the north, there's a major obstacle, the Mara River. It's do or die, yet hunger urges them on. The elder wildebeest know exactly what awaits them. They have already faced this challenge in years gone by. Once the herd gets moving, there's no stopping. Hesitate and get run over. For the crocodiles, the annual migration provides ample food to guarantee their survival. 1 out of 4 wildebeest in the herd won't see the end of the long march. They fall prey to predators or simply die of hunger and exhaustion. But most of them will make it. So for their species, on balance, it's well worth the ordeal. The feast is over. Lean times loom ahead. It may be months before the next opportunity to feed presents itself. Finally, rain. Life returns. The savannah is green. Hard times are over. Be it the Serengeti or the Okavango Delta, the picture is the same all over. When there's water, there's even time for fun and games. There's food in abundance, at least for the time being. The factors which necessitate migration are mostly ecological, such as lack of adequate food. Birds migrate from Europe to Africa, from Australia to China. Whales will cover thousands of miles underwater. Fish, fruit bats and locusts crisscross the planet in swarms of immeasurable size. Yet we know surprisingly little about the routes they take. Many secrets of animal migration remain unsolved. Perhaps these winged informants may help. Soon, the adolescent storks will leave their nest in southern Germany, destination Africa. They'll be under surveillance all along their way. Thanks to miniaturization, high-tech transmitters are revolutionizing the tracking of migrating animals regardless of their species. Researchers at the Max Planck Institute of Ornithology in Radolfzell near Lake Constance have initiated Project Icarus, an international effort to probe animal migration. Martin Wikelski is at the helm of Icarus. He intends to collect as much detailed information as possible.
Well, what fascinates us is that all animals migrate during certain parts of their life or their entire life. And in most cases, we know very little about these migrations. Where do animals survive? What do they need to survive? How can we protect them? What's the ecosystem service they provide for people? All of those questions are wide open.
Up at the International Space Station, they're installing a special set of antennae able to collect data from tens of thousands of transmitters. The system won't merely track routes and register stopover sites, but also record the animal's heartbeat and body temperature. Yet even without the sophisticated hardware, researchers have observed that many species are returning ever earlier from their winter quarters. It's the tangible result of global warming. If temperatures continue to rise, bird migration might cease altogether. This is already evident with some species. Take the black cap. Only a part of its population still flies south. The others just stay in the north, benefiting from shorter and milder winters. Some may not make it. The majority of birds, however, do find enough sustenance to survive the cold season. Furthermore, the long journey south is strenuous and fraught with danger. Some fall prey to airborne predators, while others become victims of hunger, thirst, and exhaustion. Some clever birds recently discovered yet another option. They head west and fly to England. The British easily hold the world record for dispensing birdseed. In due course, this could even morph into a new species. Those who still prefer Spain as their winter resort must cover 2,000 kilometers of arduous air travel. When they return in spring, they may find that the best places are occupied. Those who stayed behind are already busily breeding and will thus produce more offspring. It's simply a matter of cause and effect, proving that bird migration is quickly adapting itself to changing conditions. So far, so good. As long as there are enough habitats to ensure the reproduction of a species. And as for changes, that is what evolution is about.
I'm not really worried about the fact that migrations change, because they have always and they will always change. But I think it's more a question of densities or biomass of animals that is decreasing or disappearing. And that is related to the fact that many of those areas that animals need to shift to in these new migrations are disappearing or have not been protected. So the key, I think, is that we have to protect areas that allow animals to change their migrations, to install new migration routes and to have new stopover habitats.
As long ago as 150 million years, migration was a common occurrence. Camerosauruses regularly took to the track. Weighing in at around 50 tons, they were the heavyweights of their era. During summer, their lowland pastures dried out. So, Driven by hunger and thirst, the saurians headed for the mountains where water and food were plentiful even throughout the hot season. Back then as now, the search for better life conditions was the prime cause of migration. After 5 months in the highlands, and when the normal rainfall had resumed, the saurians would return to their summer habitats. It was a march of more than 600 kilometers across what's now the American West. Yet even 150 million years ago, dinosaurs were not the first to migrate. Doubtless, the earliest migration occurred in the oceans. It still does. When the sun goes down, billions of tiny organisms rise from the ocean depth to feed. Miniature crabs, larvae of mussels, and all sorts of other tiny marine life, in a word, plankton. It constitutes the lowest stratum of a gigantic food chain which keeps life on our planet going by migrating to the surface, each night anew. The blank pages in the history book of evolution are filling up. We have made great advances in reconstructing the past, but which course will evolution take? We're at a loss to look ahead a mere 50 years. Yet whatever the future may hold, mankind will have a decisive influence on things to come. From a bird's eye view, it's plain to see. Mankind is shaping the planet to an unparalleled extent. Scientists have even coined a term for it, the Anthropocene, the era of man. Our demand for natural resources makes us move mountains. Almost 75% of the surface of the Earth is somehow or other affected by man. Some distant day, the traces we leave may enable archaeologists of an alien species to reconstruct our life on Earth. It all began several millennia ago, but with the onset of industrialization, the process has accelerated. Take plastic bags. Year in, year out, 6 million tons of plastic waste finds its way into the world's oceans. They sink to the bottom and decay. Plankton and fish feed on them. In some regions, 40% of the ocean floor is already a layer of plastic waste. Soon, there'll be 10 billion of us to feed. The zones of arable land are being continuously expanded, and what once were tropical rainforests have been turned into pastures for millions of cattle. The diversity of species is declining on land and in the oceans. This too will someday be rated as a distinctive feature of the era of man. But how menacing is all this on the scale of evolution? Species have become extinct before. So far, there were 5 great waves of mass extinction in the history of life. Are we in for number 6? The list of endangered species grows ever longer. The polar bear, the tiger, and the orangutan still have a chance. If we act to preserve their natural habitats, their species may survive. Once a species has vanished entirely, it'll be too late. In his Boston lab, George M. Church is determined to achieve nothing less than a reversal of evolution. In other words, to create a veritable Jurassic Park. The extinct mammoth is high up on his list. By applying genetic technology, Church aims to mutate elephants into mammoths. During the last glacial period, the woolly giants spread across large parts of the Earth. The last specimens vanished only around 4,000 years ago.
We humans greatly contributed to the extinction of the woolly mammoth, which is very closely related to the Asian elephant, which is now endangered. If we could bring back some of that ancient knowledge, that DNA, which we can now read into the computer, we could potentially help the existing Asian elephant, and in return, it could help us to maintain very important ecosystems like the tundra in Siberia, Canada, and Alaska.
Due to climate change, the permafrost soil in northern latitudes has begun to thaw. Professor Church hopes that his recreations of mammoths will turn the inhospitable tundra back into fertile pasture. The giant grazers had been an important factor in the ecological framework. They helped to spread seeds and nutrients across their vast habitat. Today, the melting tundra releases more and more carcasses of its former inhabitants. Perfect material for the researcher.
It's like fresh meat. The DNA has been broken by thousands of years of cosmic radiation. So they're in tiny, tiny pieces, millions of them. The remedy is you paste them together in the computer using software, and then you use the computer to print them again in a fresh copy.
Professor Church intends to gradually insert mammoth genes into the genome of elephants. They would grow a woolly coat, their ears would diminish in size, while the tusks would lengthen, and they would develop a thick layer of fat under their hide. As a result, you'd get a mammoth-like elephant which thrives in cold climates.
So if people get excited about it, the way they got excited about bisons, we could have, tens of thousands of cold-adapted elephants in a decade.
Whether man should interfere with evolution on such a scale is a question of ethics. Most geneticists oppose the reanimation of an extinct species. Even if it were possible, there would be no adequate habitat for such a creature from the past. Thus, we may not be presented with new mammoths, but there definitely will be new species to come and new great moments in evolution.